Thanks, Jana. Oh, you're standing up to get up again. Yeah, she thought he was giving up his seat. Useful information. And also the core contributors actually do speak. We'll work this
Okay, we're about to get started. Again, if you're sitting on this central table, the expectation is you're going to be engaging in the conversation.
frequently.
So this is the Quic working group meeting. Let's go ahead and get started, I think. Yep. So first up, this is the Note Well. You should all be familiar with it. I feel like I've said this so many times now. If you're not, please look up IETF Note Well. It's the terms under which we participate in this work, especially regarding IPR. So the blue sheets are going out. We have scribes, correct? Fantastic, thank you. Agenda bash. So our agenda for today. Oh, great. Is here?
We need to pull that up.
Yeah. Well, yeah, there we go. That's probably good enough. So blue sheets, agenda bashing. We're going to do a very brief overview of where we're at, a little status report. We're going to talk first about a deliverable that we've chartered, but we haven't yet adopted a document for, which is an applicability and manageability statement. And then we'll go into an overview of the working group drafts and where they're at. And finally, we'll talk about open issues, a few of the issues that we've selected that we think might be useful to talk about at this meeting. If we have time, we also have a parking lot for a couple of other presentations from folks. Any bashing on that? Okay, great.
Are you going to say anything about the room?
The room.
So the experiment. So you probably, if you're in the plenary, right, the IETF is experimenting with this different room layout, and the intent is that the sort of my client statement style of interaction where somebody comments on something that somebody else said 45 minutes ago isn't really working always so great. So this is an attempt to do something different, and I think it's the first time this has been tried, so we're new at this. There's these microphones here at the front, so if you're sitting at the front, you're expected to actively participate, and you can just wave at us, or we're going to run a queue like we do at the interim meetings. And there's a floor microphone that we put back here, so that's at least somewhat in the peripheral vision. So we don't. So if you're sitting somewhere else, you're obviously also invited to contribute as always. Everybody should remember to say their names, even the front at the front maybe, because not everybody knows each other. Do tell the chairs and the area directors afterwards if you like this sort of way to run the meeting. Both if you're sitting at the conference table and if you're not. This was really sort of an attempt to see if we can break up the meeting structure a little bit and have a bit more interaction going on. And your feedback will determine whether this will happen in the future or not. And that's that. Otherwise, nothing changes in terms of how you participate here.
And if you do expect to be active, we still have a couple of chairs left up at the front table. So I don't know, Ted, if you wanted to find a chair at the conference table, or a couple other folks as well. I anticipate hearing from you. It's just a sec. So, brief status report. We had our first interim meeting in January in Tokyo. Our impression as chairs was that was very successful. We had good feedback from a number of the folks, both on-site and also remote participants, said that it was reasonable to participate remotely. We're going to be tweaking that a bit. But so far, so good. We got through discussion of a lot of issues and gave the editors some marching orders to go and incorporate some changes into the drafts. And as you see, we recently had the O2 drafts come out. So the 4 drafts in unison were released in their O2 version, and those reflect those discussions and the subsequent discussions on the list. So one of the things we did was we clarified the process for resolving issues. We've put out a consensus call for the issues that we believe that those drafts have closed. That's on the mailing list now. We're going to let that sit probably for another, I'd say, week or so, unless there's a discussion. We might extend that a bit. And if we don't hear any pushback, we're going to flag those issues as has consensus, which means that the working group thinks that those issues are closed and have been dealt with. That doesn't mean we can't reopen them. There may be situations where we learn new information, and we can certainly, as a working group, reopen those issues. But that's kind of where we're at. I forget how many that is going to close, but it's going to be dozens of issues will be closed, basically. So go and have a look at that email on the list if you haven't yet. We've also scheduled our next interim meeting in June, early June, in Paris. The details of that are on the IETF website as well as on our GitHub repo and on the mailing list. If you haven't registered for that, please do so soon. I think the registration closes in early May. So we, again, expect to have lively discussion, lots of people show up and make some forward progress there. We had 50 people show up in Tokyo. We'll see how many we have show up in Paris. It should be interesting. We also have something new. We have a badge. We have, one of the things that happened, for example, when we did HTTP2 was we needed something for people to use in presentations and on stickers and on the blog entries about the protocol. And we had a really quite poor one, and that's because I designed it. So this time around, we had a very kind offer from ISOC to help coordinate the design of a badge for the protocol. And we had a very kind offer from an agency called Occupop to do that work for us pro bono, so it wasn't any cost. They also did the HTML5 badge and quite a bit of other work for big companies that you probably know. And so this is what they came up with. So this is what we're going to be using going forward just to kind of identify the effort. So if you need something in a blog entry or when you're giving a presentation about the protocol, which is great because we want to make sure that people outside of this set of people know about what we're doing, this is what you can use to identify what's going on. And Sean over there is looking very eager. He has a couple of stickers if people want some, and I have some too.
Most of the editors have stickers, so find your favorite editor, and we're going to have more in Prague. Find your favorite editor. And the sources for this are on GitHub under working group materials, right? So you can use those freely, and you can. It's a badge, not a logo, so you can actually make variations of this by yourself if you like. Go nuts, right? Maybe don't change it completely because then it's not recognizable anymore.
Or we might even have Occupop come up with a couple of variations if there's demand for that. So go to your favorite editor, and we'll see which editor runs out of them last, and then we'll know that they're the least favorite editor.
Not everybody has the same amount of stickers.
Oh, that's okay. Fair. Finally, we've had a few questions from different folks about, they're itching to implement the protocol, itching to get to code because they don't understand how to engage in this discussion style of interaction. They want to write code and then, base their decisions and their input on that. And so talking to the editors, we believe we can get to a set of implementation drafts just after the Paris meeting. This is the terminology I think we've talked about before. We used it in HTTP2. We as a working group, designate a particular draft as an implementation draft and say, go forth and implement. And then we get back together and do some interop and figure out what we've learned from writing that code. And so the idea is we want to try and do that soon after the Paris meeting. And to get there, we really need to identify and focus on the issues that block getting to that implementation draft. That means we have to decide what we want to interoperate upon, what is the reasonable first step, and we've had a little bit of that discussion on the mailing list before, and also which issues are blocking us from doing that. And so that's what we're going to try and focus on in the next couple of months. Does that make sense to everyone, and any questions?
Are you planning to have a set of issues? Jana, are you trying to have a set of issues that we should focus on, or is this something that is just your camera?
One of the things that was suggested to me just the other day, I think by Subodh, was to maybe have a new tag in the repo, which is blocks implementation. And we can go through and look at the issues and figure out which ones we need to focus on to get there. We'll talk about that offline.
I like the idea.
So if you're standing in the back, there's a lot of seats on both sides up front. Don't be shy. You're not interrupting anything. Just me talking about something very boring, which I just remembered. So the IETF mailing lists in general have issues with organizations that deploy DMARC for email security, and don't expect me to say what the issues are, but some people can't get email and they don't get an error message, which is not great. So the IETF Secretariat has a proposed workaround that we will try and deploy to some lists to see if make that issue go away, or at least make it significantly better. And since some Quic subscribers had the issue, they asked if we would make the Quic working group mailing list one of the candidate lists on which this fix is being tested. And we said yes. So nothing should happen to you if you're currently already successfully receiving email from the Quic list. If it does, you need to let us know immediately. But there may be some glitches, or there may be some delays, or something. So I just want to notify you that that's going to happen probably in the next few weeks. And hopefully it'll make things significantly better for people who have issues with DMARC. So there's that. And nobody used this boring time to come to the front. There's really a lot of seats still there.
Okay, so next up, we've got 15 minutes for the applicability and manageability statement, or statements. Miria, I'll get your presentation up.
You want to give it a quick?
Oh, sure.
Do I have to stand in the box? Or?
Yeah, you have to stand in the box. Hang on, here's your control.
Oh, I full screen. Wait, I'm plugging something into my computer and I don't know what.
Don't be too paranoid.
It's not a USB though.
Good morning. We're talking about the applicability and manageability statement. We have a milestone on that in the charter. We had a first version. Actually, I can go to the next slide already. We had a first version prepared for the interim, and it was like one document to capture both of those cases. And basically, the only thing we discussed at the interim was to split this document up into two different documents, because it's really for two different audiences. Like one audience doesn't need to know the stuff the other audience needs to know, and we probably also end up with a different set of contributors, and that's what we did so far. So that's a little bit the table of content of the applicability statement. Some of these sections have already text, like at least one section is completely empty. None of those are feature complete, because we are trying to track what the protocol is doing, and probably there will be more stuff coming up. On the scope of the document, I already have like two things I want to potentially have feedback on, or at least remind you that you should think about it. And one is, there was already a question about, is this only on HTTP2 or is it broader? And like we made the assumption it's broader, because we thought it's useful to use this document and capture what we learned from the H2 mapping and give like general guidance for other people who want to do other mappings, because at least I would expect that as soon as the base protocol is ready, people try to use it for other stuff. And so I think it would be useful to capture what we learned from the H2 mapping. So like one example, for example, is like there was a discussion about how to gracefully close the connection, and just, listing the different steps, what an application should do to get there, could be done in this document. And then the second point is about interface. So that's mostly the transport to application interface, but maybe even the transport to crypto system interface. And currently the document talks about interfaces a little bit, so it gives recommendation where you might want to implement an interface, but it doesn't say very much concrete things. And the question is, do we want to say anything about interfaces, or do we even want to be more concrete, or is this a different document? I don't think that's something we have to decide right now, just to keep in mind. But Martin.
Yeah, so Martin Thompson, I think that probably that sort of work is fairly significant and would probably belong in a different document than this one, so that you can keep the focus here. But if someone wants to write down the sort of things that pass between the transport and the application, and constraints on those things and so on and so forth, that would be interesting. I think it might be a little foolish at this point, given the amount that we're changing things, but certainly would be interesting.
So also the approach for like both of the document for me was so far, I don't try to be here feature complete or whatever, but I'm watching the mailing list, and if I see something that could be interesting for the document, I try to write it down so it will not be forgotten. But like, I expect that everything will change over time in those documents.
I agree with what Martin said, and I was actually, this was one of my pieces of feedback was the applicability statements means like an applicability plus API statement. I'm not sure how much the API really belongs here or is but I do like the applicability part.
Yeah, I would concur with Martin as well.
So this is Daniel Kahn-Gilmore. I want to say I actually think the API is a really critically important thing to be specifying, and even if it does mean that it ends up changing as we change Quic, the clearer that we can be about the semantics that we expect to export to people who don't understand what's actually happening at this layer, the better off we're going to be in terms of people doing the right thing with this toolkit.
I don't think people are arguing against that document existing. They're arguing it to be in this document.
That's fine. I'm just saying I appreciate the API work and I want to see that continue.
Yeah, that is pretty clear. There is some API work in the crypto doc already about the individually transporting crypto. And there is, we should maybe have some more on the application to transport API to transport doc. The question of the security belongs to this one.
Yeah, in my mind, it doesn't. But as an individual, right, contributor, I think the API is too different from the applicability statement to include them in the same document. But splitting it out is not a problem, right? And Mia can have a third draft.
So that's actually the question. Do you expect this to be discussed in the protocol specs, or do you want it own?
I don't think we know.
Okay.
It might make sense. I mean, 793, it was in the protocol spec, but that was also, you know, it's not really a modern document, so to speak. But so it's a decision for the group.
No, I mean, like, I totally agree. And currently the document talks a little bit more about interface than it should be, but it doesn't, no other document talks about it. So as soon as we have this text somewhere
So
else.
did you feel like you needed to talk about the API so that you could talk about applicability?
So currently it doesn't talk about like a real API. It just said like, here's some piece of information that might be useful to expose to the application. And then because you like what the document should do is talking about what you can do with this information. But
Okay.
like first you need the information.
So just to correct, there is, so you mentioned this document family doesn't talk about transfer application API, but it does put crypto API functional is there in the crypto document.
Yeah, I don't think we talk about the crypto API in this document anyways.
Going on tap right now.
How the heck do we know what's going on here? We just hear people talking across the room.
Yeah, so-
there's no queue. This is difficult, Lars.
That's supposed to be a feature.
Yeah. it is a feature, Lars.
But yeah, people, it might be useful if people say their names or maybe sort of raise their hands so that the people who aren't at the table can sort of roughly see where the speaker is sitting, because it comes out of the same speakers in the ceiling, so it's hard to locate folks.
So, but there's also mic line, right?
Another problem is sitting back here, they have no idea who's speaking.
Yeah, so let's try the new protocol of, you know, raise your hand if you are speaking at the conference table, and maybe that helps. So as I said, right, this is an experiment, and we're figuring out things about it.
And now Gori is at the mic line.
Oh, hello. I found a question. I'm Gori Fairhurst. I suggest that the idea that will circulate around the discussion of having a separate document is really good. And the best thing about having a separate document is when we need to update it, and we can just have an updates against that, and the document can be long lasting. Whereas if we have it in an applicability statement, it really gets messed up.
Just a quick check. Can people hear this one?
Yes.
Yeah.
Okay. Oh, the
What's your name?
Jana Iyengar. If people can't hear me anyways on me.
So Lars, like, do we have a problem with the remote audio? That's what's happening? Just that mic. Okay. There was somebody from Meet Echo here earlier. Maybe use that other mic on your right-hand side, and we'll figure out what's going on with this one. Yeah, so that's the magic word to mention.
Testing, 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 testing.
Okay, I think we agree more or less, so I move on. No, that was the wrong direction. Manageability, so that's the table of contents of the manageability document. Here the approach is like slightly different. We have like one section where we try to explain the protocol a little bit on a high level, and the second section is more structured by use cases and discusses about how to use information that are exposed by the protocol for a certain use case. There's actually some new text here for new use cases since the last version, but there's also still some empty sections. So it's all work in progress. And like here, it's even harder to capture the current protocol spec because so many things are changing and are under discussion. So yeah, so it's definitely not feature complete. And I'm not even guaranteeing that all the information in the document are like fully correct. But I've been trying to capture some of the discussion that's ongoing. And also, like, we updated this document before the last protocol version was submitted, so we just made some assumptions about changes that will go in there.
Just Sean Turner, I felt that was pretty clear that the way you wrote the document said this is work in progress.
Okay.
So it was okay, I think, to just do what you were doing.
Good. So this the audience for this document is like network operators and vendors. And we've tried to follow closely the document. There are a few editor's notes in there, and like if we're going to adapt the document, we will remove them all because they go a little bit further than they should go. But like currently, the editor's notes are in there, so it's a reminder to myself so that I don't forget about it. But they will probably go into an issue either for this document or for the protocol document itself. And that's also a general point. If you have issues, you usually have issues with the protocol, and you should put an issue on the protocol document in and not on this document, because this document is only trying to track what the protocol documents are doing. This is not for discussing those issues. Comments? Do you want to ask for adoption, or?
I think that's the next step is we've talked about these documents, or first the document that combined them and now the two documents for a little while. We are chartered to deliver something. How do people feel about adopting these to meet that charter deliverable? Any comments before we take a hum? Okay, so let's take a hum.
Who read them?
Who has read them? Hands up.
20? About 20 people?
Lots. Maybe 30.
Yeah.
And we do look for contributions because it's a lot of different things here. So if you have contributions to one of the points, we're really happy to take that.
So let's take a hum. Who believes that we should adopt these two documents? I'm assuming we're doing them together. Yeah. And who believes we should not adopt these two documents? It seems like pretty strong support.
Yeah, it does. I didn't hear anybody.
Well, yeah, but we didn't seem to have any pushback on that. So.
Yeah, so for the record and for the minutes, right, that was a lot of hums in favor. I didn't hear any hum against. So we'll confirm this on the list, as always, and then we'll figure out where on GitHub that thing lives.
Yeah, I would actually propose an own repo because I don't expect as much issues as like for the protocol specs, and if there are any issues, then it's probably different kind of issues. But, yeah.
Do you mean you don't want to receive like 1,000 emails a day?
I already get this, right?
You're talking to an area director, man.
So that's why I said you just want another 1,000 emails.
All right.
Thank you, Miriam.
Thank you.
Drop it by on the way back. So next up, we'll go into overview presentations. I guess status updates on the thank you of the 4 drafts that we have adopted so far. For those 2. First up is Quic. Is this going to be transport? Sorry. Yes.
Jenna.
Jenna or Martin? Jenna.
Jenna.
Jenna. Jenna, stop. Maybe just leave it next to Patrick there when you're done.
Jana Iyengar, I'm just going to go over one of the editors of the document. I'm going to talk about a few and then Martin's going to talk about a lot of the other changes. So this is basically not working.
She might have turned it off.
It's working. Yeah, this is all work in progress. Pretty much all the changes that we have here are proposed changes, and certainly it's possible to come back in the future and change it again. But we need to make forward progress. We need to move forward, and we have lots of changes. I'm going to walk through each one of them. I hope you can read this font. The first one says, I'm not going to do that. So the list, this is basically the list that Mark sent out earlier to the working group list. So please feel free to go back and look there, but it's a lot of changes that we've been doing. So we've been busy over the past few months. I'm going to get into some detail on one of the big changes in the draft. And this is change to the header format, the Quic header format. So the old header, the old Quic packets used to look like this. We had regular packets, which had flags, optional connection ID, optional version, a packet number, and an encrypted payload, which was constituted by different kinds of frames. There were unencrypted packets. The version negotiation packet was one of those, which looked like that, and the public reset packet, which was unencrypted, which looked like that. The handshake packets were effectively just regular packets, but not encrypted. This is how the older wire format looked. There were a number of issues around this, including the fact that this had a lot of different, there were a lot of combinations that did not make sense in the flags byte, for instance, but existed as options. And we were losing space there. It wasn't an efficient packing of flags. It wasn't an efficient packing of the way that we could have headers. And it resulted in a large variety of header formats. So the proposed one, after a lot of discussion, after a number of iterations, they were on the list if you've been paying attention. There were proposals and then reproposals and then iterations. The draft now contains a new format, which I think is one of the things that we're going to call, I assume we're going to call consensus on later. The header format splits Quic headers into two types of headers. The long header and a short header. I'll talk about long headers first. The long header is identified by simply a 1-bit marker at the beginning of the packet. This is in the first byte of the packet, and if it's 1, the first bit is 1 in the first octet, then that's a long header packet. The bit is followed by a 7-bit type field. So that whole thing is 1 octet right there. And I'll talk about the different types that exist in a moment. There's a fixed and permanent, not permanent, a fixed and always present, not optional connection ID field in a long header. There's a fixed and always present packet number field that's 32 bits long in this header, and there's a version field that's also present in this header. The body of this packet depends on the type. Not just the body, but even what's contained in connection ID, packet number, those two fields specifically kind of depends on the type of the packet itself. This packet is not always encrypted because it's used. So the goal is that this particular long header is used for the initial part of the connection, where it's used for all the handshake. It's used for, in addition to the handshake, it's used for special things such as version negotiation. It's used for sending a public reset packet. Those are different types here. So the different types that you can have of the 128 that you can have, that we have defined at the moment only 8. As you can see, 01 is version negotiation. And in version negotiation, the payload is basically a version list. 02 is client clear text. This is when the client sends the initial handshake packet to the server. That's type 02. If the server sends a final, yes, this handshake is finished, that's final server clear text 04, and any intermediate packets that the server sends that are part of the handshake are 03. Zero RTT encrypted packets are encoded with 05 and 1 RTT with 6 and 7. This allows a receiver of these packets to not have to do trial decryption of the packet, because this explicitly encodes the key to use to decrypt the packet. This was not the case in the previous header format, by the way. The previous header format, you did not know what the key was, so you had to explicitly go try various keys before you could decrypt the packet. This explicitly lays out which key should be used for the packet. 08 is public reset. The definition of public reset is to be determined. It's not done yet, but we've reserved that for public reset. The key phase 0 and key phase 1 are to allow for a, what's the phrase I'm looking for? It's Thursday morning.
You've already covered that part, so it's all right.
Okay, good enough. Sorry?
It's a key update.
A key update, thank you. A key something. Yeah, key update. And I'll move on. The short header packet looks slightly different. It is optimized for the rest of the connection. It's optimized for when you have the one RTT or the forward secure keys, or basically you're finished with the handshake and the connection is now going to use this for data transfer going forward. So it's convenient to be able to optimize this. We don't need, for instance, versions. Versions are not needed in here because we finished the handshake. We don't need versions anymore. So this is not to scale, by the way.
You don't say.
It's not to scale, but it's built for readability. All right, fine. The first, that's one octet up there. It's 3 bits, 0CK, and then a type field, which is basically 1 octet. The 0 that indicates it's a short form header. The C indicates that a connection ID is present in the packet. Now, this is useful to make the packet self-describing so that middle boxes, stateless middle boxes that need to use the connection ID to determine where to send the packet will be able to find the connection ID if it exists. And if it doesn't exist, then they can't, of course, use the connection ID. The K bit is used again for key update later. If you need to flip the key and you don't want to do trial decryption of packets, then you use the K bit. There's 5 bits for type, which gives you 32, but we are using only 3 of them to specify what packet number size is going to be used in this packet. And then it's encrypted payload. The details are in the draft. I will go over one specific detail because this is a functional change. It's a significant change from what the previous spec said. And this is that the new format now allows for a server chosen connection ID to be used for the connection. The way this happens is that the client first chooses a random 64-bit connection ID in the initial packets, and the server replaces that connection ID with its final, what we call the final connection ID in the final clear text packet, which is the end of the handshake packet. And all client clear text packets, various packets that are sent before the server sends this are all sent with the client's connection ID. Once the server sends the server final handshake packet, that one and subsequent packets from the server and all 1RTT packets from the client are all use the server chosen connection ID. Ted?
Ted Hardy. It's probably just because I'm sitting near DKG, but it just occurred to me that there's a potential privacy issue here. And that is, we've been talking about changing the connection ID and the packet sequence number when the client knows that it has changed network.
Yep.
Obviously, in this case, would we consider that a moment at which the server could choose a connection ID and force it back to the original connection ID, or does this occur only once?
This occurs only once.
Okay, and so I think then that handles the problem. Although
Yeah.
I
do
think that there's sort of a secondary thing that we may want to look at in the future. If they force them back to 0 RTT, they could then force them back to this original connection ID.
But you couldn't go from, you will not go from 1 RTT to 0 RTT. I don't know. How you
No, I mean, if I refuse to take the packet flow on the new connection as a connection transfer, I can do 0 RTT to restart it, and then you can get back to the original connection ID. So I just thought of this, and it may be completely crazed, but it's something we may want to look at as we're going forward.
I don't see how that can happen, but Mike wanted to say something, and then the rest.
So Mike Bishop, that's something that we've been talking about both on list and inside conversations. And basically the idea for the connection ID change is that, and I think Ian was going to open an issue for this so we can track it, but we'll add a frame type where the client can say, I would like to have a new connection ID that I can hold in my pocket in case I need to change.
So if you're talking about connection migration, so we haven't actually figured out what the signaling ought to be for the server to send other connection IDs for the client to use. This is not that. This is merely at the beginning of the connection.
So I guess several things. Don't get too attached to that design, because I'm going to be presenting a much more radical connection ID design pretty soon. Generally, I think it's important to understand what the threat model is here. The threat model tendency to have in its head is the server is attempting to force you to produce some connection ID that allows third parties to track you. That is hopeless. Like, trying to stop that, I think, is not like actually a useful thing to do. Because it's trivial for the server to simply emit a packet collinear to this packet that you will discard that will bind the 5 tuple to any tracking identifier he wishes. So I do not think it is a useful attempt to stop the server from colliding and tracking.
Victor.
Victor Vasiliev. So do I understand correctly that this is the only reason we have the final clear text packet type? Or I'm not sure I understand the reason why we need to distinguish final from non-final.
Yes, this is the reason why I put that in. That's right.
So is there any reason why? So the reason I'm skeptical of the scheme is that we could do more, as in we could provide multiple connection IDs at once at the very beginning of the connection.
So as I said, this is not a functional change in that this retains the one connection ID per connection. We have not yet figured out how to actually ship multiple connection IDs, and I think that's a separate issue, to be honest. That has to happen outside of the packet header, probably.
Indeed.
But we don't know how we're going to do that. You could ship it as part of the server hello message, or you could ship it in frames, or you could ship it in a separate TCP connection. I don't care. But we don't know how that's going to be delivered to the client, and that is a separate issue from just getting the handshake. The server to choose a connection ID for this connection instead of the client choosing it.
Mic check for Echo.
This is DKG. So just to comment on the discussion between Ted and Ecker here. I agree with Ecker that there is no way ultimately that a client can stop a server from de-anonymizing the client if they want to, right? The server could publish a new HTTP endpoint that says, ask me about my clients. and you wouldn't know, right? So it is ultimately impossible for them to do that. However, that doesn't mean that we shouldn't design this protocol with guidance in mind for servers that say you should not de-anonymize your clients by accident, and we should make the mechanisms available for it. So please don't let the fact that it's impossible prevent us from making it difficult to do in band.
I absolutely agree that we should make it so that you would have to go to explicit effort to do so, not that you should do so because you just know what you're doing.
Subodh Iyengar, question. So should we make it a requirement to, right now I think the requirement for Quic is that your handshake protocol has to have 0 RTT mode. But should we make a requirement then with this that the full handshake, like the non-0 RTT mode for the handshake, has to only take 1 RTT in that case?
Because
in this case, if you say
there's no requirement for a 0 RTT.
So in this case, like if we use the last clear text packet for a connection ID for the client to bind to the connection ID, let's say a multi round trip handshake protocol would you would send the new connection ID, and then the client would then route it to a different backend server. So you'd have to use you couldn't use the client's connection ID anyway. So you'd have to use some sort of you'd have to use the 5 tuple for routing in the backend. So really, was the client's connection ID really useful in that case then? Or
so Subodh, the design here is Martin Thompson. The design here is specifically designed so that in the 1 RTT mode, the server immediately picks a new connection ID and uses that for all the packets that it does. And you can't have that in the general case because you need hello retry request, you need the stateless reject, and in the stateless reject case, you want the server to process the client hello statelessly, and the best way to do that is to simply have it echo the connection ID. And I think John's design.
So my general question was basically, what is the point of the initial connection ID? The client actually sending a random connection ID in the first case, because you can't use it for routing anyway for multi-handshake protocols.
Maybe you can. John?
Yeah, so the client connection ID is what's used in deployments right now for Quic. And so it allows us to basically say the server's choosing the connection ID and the server chooses to use the clients.
Right. So in that case, in multi-round trip handshake protocols, the client. So if the server chooses if it wants to land back on the same server, I see what you mean.
So
like it would
it
just still use the client. Would
It
still,
doesn't matter what you do at the beginning. It's going to be either zeros or it's going to be a random number.
Right.
And there has to be some special
Okay.
logic to
So
handle
the server
those
could
packets.
choose to use the same client's connection ID anyway.
It will.
It can, but it can change it as well. Yeah.
Well, it should only change it on the last one, at the end of the handshake, so that there's no confusion.
Okay. Fair enough.
Jim Roskin, two comments. One is this area is probably worthy of like very careful debate because this is the most ossifying element in the world. You're going to see routers paying a lot of attention to it. So my next comment shouldn't be interpreted as nitpicking so much as just concern for a very central area. The original design of the full 64 bits was to deal with the birthday problem. And that's why the connection ID was so large in the initial statement, so that there would be very minimal chance of a collision. Once you get to the point where the server gets to select what the actual number is, the connection ID to be used, you no longer have that problem. And you have a significant potential for noticeably reducing it. At 8 bytes, my hands are waving violently when I'm calling that 1% of the traffic when you are using it, but maybe it's a 0.5%, I don't know. But it's a noticeable percentage of the traffic. So this is an opportunity at a very central place to consider having a smaller connection ID that could be handled, as I say, and this is the most ossifying firm thing that you're going to have probably.
I'll respond in 2 ways. One is that this allows for you to continue using a client-chosen connection ID. This design right now allows for that to continue being the case. It's up to the server if it wants to slap a larger its own connection ID or not. The second thing is that for most of the packets, the expectation is that the connection ID is optional and therefore can be completely left empty.
And to be clear, certainly in the client, the server case, given the NAT rebinding, a connection ID of some sort will be of great importance. So although it's called optional, it's probably a lot less than optional.
Well, in the server to client direction, it is not necessary. But Martin, you wanted to say something?
I think I'll let Hannes comment first. I think he was in line before.
Okay.
Yeah. Hi, this is Hannes. I was just wondering, some of you've been in the TLS meeting where we actually discussed some of those topics already, and it feels like almost like a replay, but it's just that we lost state in between the TLS meeting and this meeting.
Yeah, and the DTLS meeting
feels like a little odd. Yeah, like
Hannes, the DTLS meeting feels like a replay to me when I show up there too. So I think it's by design. But I'll be clear about one thing though, that we are not trying. There's an agenda item later if we have time to get to it to actually discuss connection ID and its implications.
Let's not rat hole.
Yeah, I don't want to get into that. This is not changing that state of the world.
Yeah, that's slide 6 out of 14.
So Lars makes a good point, but I think that the comment that Jim made was actually separable from the discussion that we're having separately later today. And I just wanted to address that. The connection ID isn't big enough for a lot of use cases at the moment. And that's actually the tension that we have here, is that for depending on who you are and what your use cases look like, 64 bits is miserably small.
Yeah.
And at the same time, I agree, it's also humongous. We're burning a lot of bytes on this thing, and we're taking great care, as you see here, to shave off bytes as aggressively as we possibly can, and inducing complexity in the process. But then we're shoving an extra 8 bytes of basically useless entropy into every packet that also happens to have some interesting privacy consequences. So you're right, there's a balance to be had here. I think that we're going to stick with 64 up until the point that we actually have a much firmer grasp on the problem.
The interesting privacy consequences conversation is the one we are not having right now. I'll note that this particular header, and I did want to say this earlier, that in the common case, if you're not sending connection IDs in the HTTP case in the server to client direction, then you have a 1 octet, and then the connection ID is missing. The packet number can be 2 bytes. So you can have or 1 byte. You can have a 1 to a 2 to 3 byte packet header, which is in the common case, which is quite nice.
Hi, Todd Short from Akamai. As someone who's worked with hardware implementations of protocols and had to deal with TLS and its 5 byte header, is there any way we can get this to be a nice, even byte size?
Oh boy.
Well, actually,
I mean,
the answer is yes.
Yes.
Sorry, Martin Thompson. The answer is yes. But Jana has a lot of experience working with hardware as well, and he tells me that it doesn't matter. So it varies, and the cost of that is we're going to spend extra bytes. Have you got a use for those bytes? Because if we have a use for them, then certainly we should, yeah, understood, right?
So, yeah.
We understand that sort of tension, and if we can find a use for them, then we'll probably use them, but I don't see any.
Praveen Balasubramanian, a general feedback on the header format. It concerns me that there is no reserved space that we're putting there, given that this would get ossified very fast. The second concern is the start of the payload does not have an offset. Like in TCP, you can extend the plain text header, for example, in the future, but hardware, for example, would not be able to know how much to skip if we decided to add more feeds in the plain text part of the.
So the type is actually, equivalent to reserved fields. We have, in this case, 3 out of 32 types defined. The remaining 29 types are undefined. And in this case, only 8 out of 128 are defined. The remaining 120 remain undefined. Those can change the header or extend the header if you want to. The format, so if you have old hardware, so we did think about this quite a bit. If you have old hardware or old devices parsing this, then you will have to pay attention to the versioning and the version negotiation that happens up front. But yes, we could do this with versioning. We could combine that with versioning and go forward with additional types.
Okay, and one minor feedback is we did not talk about UDP checksum in the draft because in IPv4 UDP checksum is optional, so it would be nice to make that clear whether it's mandatory or not.
So we have a checksum. I think we are going to talk about that briefly later, right? So
I think we have an issue open for the checksum. We simply haven't written down our conclusion, which is that if you can, don't put 0 in there. But that's basically all we can really say in practice.
Yeah, but we also have, the plan is also to have a hash for quick packets. Even all of the quick packets are going to be hashed. So, and they're going to be stronger checksums than the IP one.
Igor Lubashev, Akamai. That's exactly actually the point I was trying to talk about, is that we were considering adding a hash because UDP hash sucks. Yeah. And that could be the area, the bits that are occupied by the hash.
That's coming up next.
Nicer.
We're going to talk about that next.
Mirja Kulevin. One question on the connection ID again. So is the assumption that you either have a connection where you basically have it always set or never set, or would you just have this like on a per packet basis decision when to set it?
So the connection ID bit in the short packets basically allows you to do this on a per packet basis.
I know it allows you, but like, what's the assumption? Does it make sense to set this on a per packet basis?
In the common case, no. I mean, so in the client server case, you would expect that the client would negotiate. So the way that Google's Quic right now works is the client sends connection IDs on every packet, and the server in the bandwidth intensive, in the bandwidth sensitive direction, does not send connection IDs because we'd like to save bits there. And it works out well because the NAT binding happens on the way up, and on the way down, you already have the binding available. But the connection ID bit is present there in order for middle boxes which may not know directionality, which may need to find the connection ID in the packet to know whether to look or not.
But basically, if you have a NAT or not on your side, is a good guess, right?
What person behind you back there?
Jonathan Looney. I have just one. What's it? Hello? Yes. That's uncomfortable.
It's supposed to be.
You're trying to discourage feedback, aren't you? My only feedback is I think it would be good to involve a hardware vendor sooner rather than later to make sure that whatever header formats you're using will be easy for them to optimize in hardware. I just think it'd be good to have a consult with someone who does.
Absolutely agreed with that. If anybody wants to do this in hardware, please come up and talk to us. That would be the kind of diversity in implementation that we would love to have. Yeah, definitely come up and talk to any of the editors or the chairs.
Yeah, I guess I wanted to register, like, basically, I agree with Maria here. Like, I don't understand why this, having this on a per packet basis is useful. And I understand this, I don't find this argument that we should be able to tell middle boxes what the connection ID is all persuasive. Exactly, it's an ossification problem. It's not an anti-ossification measure, an ossification measure.
What, connection ID itself?
No, having a bit from the middle box that says connection ID is here is just gonna make the problem worse, not better.
Which problem was?
The problem of ossification and middle box enforcement
Of connection IDs?
of the structure of the packet.
And that's going to happen no matter what we do. So there's
Yes. Okay. Let me just say, I'm not persuaded by this argument. I don't consider it closed.
I think may agree that every information you expose will be ossified. So
We're trying to run a queue.
sorry.
Robbie Simpson, can you go back to the long header?
I'm trying.
Is there a reason the version fields last instead of not up front and center for extensibility?
For extensibility. Well, no strong reason.
No, there is a reason. The connection ID is always at the same position.
And well, so I was going to say that's the one when connection ID is present, it's in the same place in this and the short header. But and so it's the packet number. If the connection ID is also present, and the packet number is also in the same location. So that's convenient, but not strictly necessary.
Okay, I guess my thinking is, and I don't know, maybe in the far future, we decide packet number shouldn't be 32-bit or et cetera, et cetera.
Yep.
So usually you put version fields at the beginning, but.
So the idea here is that you could, if you wanted to extend the packet number field, you could always add more bits past the version field, for instance. So there are ways of extending it that allow ossification of the exposed fields now and allow us to extend those fields in the future too. Although if you think you're going to need, if you need packet numbers greater than 32 bits, we can we can make it 64 bits and then for all eternity be happy. People have suggested that, by the way. So I'm just going to move forward. These are the fields that are expected to remain fixed across versions. Maria.
Sorry, one more question. Because you said earlier about extensibility. If you have a new type, you have to figure out if the other end understands this type, right? And is the assumption that you would also update the version if you define new types, or is there a way to define new types and keeping the old version?
So extensibility in general remains not fully well defined in Quic at the moment, but yes, that's roughly how I was thinking about this.
Okay.
So we are running a little behind.
I'm going to try to be quick.
Yeah, it's not unfortunately not only up to you, but
Can I yell at someone if they ask questions?
Yeah.
All right. So yeah, we did that. We sorted out versioning on the list and at the interim. That's all in the document now. We now have the ability to grease the version field. I don't know if that's going to be successful or not, but that's just how we are. There's a scheme in here for identifying the versions of drafts from the point that Mark talked about earlier. When we actually start implementing drafts, we don't want to create a situation where those drafts are conflicting with the real things. And yes, we defined transport parameter negotiation. Some of this is going to change likely, but the basic idea is that the TLS layer provides a field that contains all the information that Quic needs to know how to configure itself. And this field also authenticates the version negotiation that happens in Quic. So Quic does its version negotiation without any cryptographic protection. We need to double check that everything is fine by putting all that in the TLS handshake, giving that integrity protection. And that way we know that the version negotiation wasn't tampered with, or at least wasn't tampered with to the extent that it has a material effect on the outcome. If that is incorrect, I would like to know. I'm not 100% certain that this is correct. Some analysis, the rough analysis that I've done suggests that it's okay, but if someone can prove that this can be broken, I'd be interested in learning that. We also added the ability to have default values for these parameters. The original version of Quic required that the parameters were negotiated in the connection, but it didn't really say anything about what to do during 0RTT. And so the decision that we had at the interim was that during 0RTT, the client can either use the values that it got from the server last time, or it can use defaults. There's a new section on path MTU discovery. Thanks to Martin for that one. The other Martin. There's too many Martins. And we also now require that the initial client packet is 1280 octets or larger. And we do that so that we can deal with the amplification attack problem. Victor.
You mentioned that the clients can choose whether to remember defaults or not.
That is the decision.
I hope they indicate which they're using.
They do not. And this is the source of my objection to this, but I suggest that we table that discussion for later because we have consensus around that particular issue. You and I might agree on this, but.
Magnus, do you want to say something?
Yeah, Magnus Westland. So about the path MTU discovery, it's good that there's a start there, but I think it's fairly long. It needs much more text to actually be usable for somebody to implement against.
Excellent. We have a volunteer. Thank you. There's also a requirement now on the TLS side of things that if TLS is going to send an initial handshake packet, it needs to fit within this 1280. We don't actually say the 1280, we actually say that it fits within the initial packet. So obviously, if you know something about the path MTU and you're able to send 15 kilobyte handshake packets, then you are quite free to use some post-quantum algorithms in your key exchange. Otherwise, you need to come to some other arrangement. That may entail extra round trips. All right, so there's a whole bunch of things that we did around acknowledgements and dealing with loss, and probably one of the more interesting ones is that we had a stop waiting thing, and Ian observed that it wasn't necessary, so we did a lot of work around that. That's gone. We now no longer acknowledge frames that basically don't include any information. So if you're only acknowledging things, you don't send an acknowledgement in response to that. If you find that you're only acknowledging and you want to see some sort of feedback from the other side, send something to them. That's not one of these things. We suggest ping. There's a discussion about using window update for that purpose, which I think is good for different reasons, and both of them have their advantages. There's also the recognition that if you acknowledge a packet, that means that you did something with it. Now, for most packets, that means fully processing them. For stream packets, it just means take the payload of that stream frame and stick it in the receive queues. We have an explicit acknowledgement for the consumption of packets, which is flow control. So that's different. Streams aren't closed until the data until you've sent everything that you intend to send on the stream and you've had that acknowledged. So basically, your send buffer is completely flushed, or you get a reset stream. That wasn't clear before. The text was talking about things like if you send a fin, then you're done, which is clearly not the case because there's probably something hanging around in the case of packet loss. And the other thing that's kind of interesting here is that we have a lot more text on how we deal with retransmissions of lost stuff. And the observation here is that you don't retransmit frames. You retransmit the things that were in the frames. And so one of the earlier discussions was, well, when someone sends a stream frame of 100 bytes, do they have to send that exact stream frame again next time? And the answer is no, they can send however many bytes of that stream frame they want. They can stick a few extra in, they can take a few out, it doesn't really matter. The whole point is that you're sending the information. And this applies to streams, to the packets that we're acknowledging in ACK frames, to flow control offsets, and basically it's uniform across all of the frame types that we have. Frame layout. So we made a bunch of changes to the frames. We moved length fields around. Go Away had some stuff in it that was vestigial. We're going to talk more about Go Away later on when we talk about moving Go Away entirely to the application layer. I'm not sure where we are with that one, but it seems quite likely we might do that. And we've had some rationalization around things like connection close and reset stream. Lars suggested that it was very nice to be able to place frames in a sort of fixed locations, and in order to do that, sometimes with the variable length things, you end up with little holes. And we said those little holes are okay, padding no longer goes from the 0 byte to the end of the frame. It's just 0 bytes wherever they appear. And so you just skip over those ones. That allows for different strategies for assembling packets. And there's a bunch of other stuff here that I won't necessarily go through in detail. We randomize a bunch of things. TLS now does the bulk of the source address validation. And I think the text has actually been changed a little bit because it now talks about client address validation, because clients can't validate the server's address in any way. They don't have any option to do so. Sorry?
Clients inherently validate the server's address by completing the connection in the first place.
Yes. Well, they're in some ways, yes. And
in what ways, no?
So if you're talking about if you receive a version negotiation packet, the validation is correct based on the fact that you receive an echo of the packet of the connection ID. But in the case where you get a multi-packet server hello, there's the possibility that one of those packets don't contain any acknowledgement of the things that you sent in your packet.
Sure, I don't disagree with that point, but the essential principle here is the client gets the server's address from a trusted location, which is to say DNS, and the client is happy to send essentially a full connection window and 0 RTT to the server. So I don't really see how it's like.
Yes, sure. You just said trusted DNS, by the way. I'll get you on that later.
It's a bad word, I know, but nevertheless, that is the concept.
Right. We move priority to the application protocol. So the application protocol is responsible for any signaling necessary for prioritization. Maybe different protocols don't have prioritization in the same way that HTTP does. Maybe they don't have signaling for it. Maybe there's all sorts of reasons for doing it that way. But the transport is expected to listen to whatever the application says about priority. And we rationalize the state machine a little bit. We may do that further in the future. And I think that's the end because it's not clicking anymore.
Yeah.
14.
Fine.
Thank you.
Thank you for making good on your promise.
Who wants to do TLS? Is that you or Sean?
I don't really need the clicker because I only have one slide. Personally, I hate these kind of presentations because we're doing all the things that were agreed. So let's see if I can make this work. Great. That's not all the list that I had. Oh, well, whatever. It's pretty short because Martin's actually already talked about some of these. So basically, the first big change is we put the entire handshake is now unencrypted because basically, Echo pointed out, I think at the interim, there were some parts of the quick handshake that were encrypted and some parts weren't, and we basically just put it all in stream 0. It makes it easier. So when you're done with the connection, you can just have the keys. It made it a lot simpler to explain, and we moved on. Hey, we've got this AEAD thing. Let's use it. Check. The alerts is the stuff that Martin talked about earlier, and for looking at TLS versions, the way we could write the API for the stuff is that you could use earlier versions, but you wouldn't be able to get all the features. And one of the big things about TLS 1.3 is that it has 0 RTT, and Quic really wants that. So we kind of pegged and said, you got to use at a minimum, use TLS 1.3. And as Martin talked about earlier, we decided to find some more transport parameters to stick in as TLS extensions because there were a bazillion of them before, and now there's a whole lot less. And that's really it. My kind of hope is I can just yield all of my time back to talk about the actual issues. So.
Yeah, Quillivan, quick question, and I didn't read the document, but the transport parameters, is this something that should actually go into the applicability statement? Like if you want to use something else than whatever, this is what you need as well?
I don't think so. Janai, I don't think so.
Okay.
The transport parameters are really about what the transport's negotiating with the other side. I
Yep.
don't know that makes sense in the applicability statement.
So no, what I'm wondering is,
The applicability statement will likely not be standard struck.
no, I don't want to take it out of this document. I'm just asking if we should say something about those parameters in the applicability statement, because I mean, like, I don't think that people go up and invent their own crypto all the time, but I guess there's at least like one point where
You'd be surprised.
but if you have like pre-shared keys, for example, you don't need the handshake there. And then what do you do with those parameters? Like, where should this be discussed?
Mark Nottingham, it seems like there's almost another document floating out there, which is how to write a new version of Quic or a divergence of Quic. That seems like a method there better.
So, Mike Bishop, I think what you're getting at is if you're using some kind of crypto handshake that's not TLS. And in the transport document, I don't think we wound up taking this out. There's a list of, if you use a different crypto handshake, it must provide the following features. And one of them is it has to be able to transport these parameters from one side to the other.
Jana Iyengar, we did take that out.
You did?
Yeah. The crypto handshake requirements section is gone. I mean, it's been incorporated in other nice ways. Yes, I know that.
Okay.
But
We should check that.
but it's not explicitly present.
Kyle Nickerts, when you say the entire handshake is now encrypted, is that just referring to the client flights or also the server certificate and server flights?
I believe what Sean means is that it's not encrypted at the Quic layer, but it's still encrypted in the conventional TLS way.
Yeah, so you're like, you use the TLS encryption because it's already there. It's the, yeah, you can't.
Just avoiding double encryption.
Right. Exactly. And great, I will yield my time back to the issues. Thank you very much.
Okay, next up is recovery. Ian?
Sorry, Mike.
Sorry, I got out of order.
Yeah, I have one slide, so the clicker is super important. One note actually is that some people couldn't access the slides. On one page, the slides are PDF, and one page they are the Google Docs ones. If you go to the, I think it's the IETF 98.
They're PDFs in the proceedings.
In the proceedings.
Yeah.
If you go to the proceedings page, everything's in PDF and it's accessible. So all the people who are asking for access to my Google Doc, it'd be easier if you just got the PDF. Thank you. All right, so let's talk about recovery. The main goal in the last 4 months was to kind of get the doc into a little bit more self-consistent and contained state. We've added time-based loss detection. We fixed early retransmit, which was completely wrong before. We had some clarification and some text on how handshake packets are recovered.
Can you go a bit closer to the mic?
Sure.
Thank you.
We made all references informative, or at least all TCP references, under the idea that at the interim, as well as at the previous IETF, people wanted this to be a more self-contained document. They didn't want to have to read 14 TCP RFCs in order to understand it. And so a lot of the work has been to move towards that goal that's more self-contained. Includes RTT calculation for things like SRTT and RTT variants that are commonly used. And in the editor's copy, RTO and FRTO are now much more accurately specified. New Reno is now been added. Obviously, New Reno is very simple, but at least it introduces the idea of things like bytes in flight, introduces the idea of recovery period, things like that. So I think my main message is, at this point, now would be a great time to take a look at the editor's copy, not the O2, because it missed a few key changes, and provide me feedback, and John feedback, and anyone else feedback. And the best way, for me at least, would be actually to file issues, because occasionally the mailing list gets a little busy and things get dropped from my inbox.
And could you publish a 03?
Huh?
Could you publish a 03?
I certainly could. I thought there was an agreement that if I published a 03, everyone had to publish a 03.
I did not realize that was the idea, but we can. That's easy to do.
It makes it really easy if they all are in lockstep. Now, that doesn't mean we can't do O3s of everyone.
I am happy to.
Yeah, so I think probably what we want to do here is a very short time after the meeting, we'll do a 03. We just need to make sure that we don't have anything in a bad state. Oh, and so on that subject, 02 was very, very large in terms of difference between that and the previous version. And that was largely because of this header format issue that was going to be so fundamental. We expect to be issuing new versions of drafts on a much more regular basis, and Eka's request is exactly on time. We expect to do one before and after each meeting, and likely, and then before the interims, certainly.
Praveen?
Yeah, so I had a question. So based on Yu Chung's talk yesterday in TCPM, they removed early retransmit and FAC and a bunch of other mechanisms from the Linux congestion control. I wanted to ask if it's an explicit goal to track what the Linux kernel is doing here, or is this going to be its own set of congestion control mechanisms?
The mechanisms are very similar, but they are applicable to Quic. So when I say it incorporates early retransmit, it basically does the exact same thing that RAC does. It incorporates the concept of early retransmit. It doesn't actually, it's very much more along the lines of like what Yucheng's TCPM talk is.
The charter talks about using a standard congestion control mechanism, right? And we can, as long as what the Linux kernel is doing can still be considered standard from an IETF perspective, that should be fine. If it's not, then we probably can't roll it in because the charter prohibits it.
Yeah, for congestion control, I think we'd want to stay with New Reno for the foreseeable future, if only for simplicity. But for recovery, I think we're in okay.
Jana Ingar, I think it's probably valuable to separate loss detection from congestion control. For loss detection, yeah, Quic's been doing things differently, but has incorporated the spirit and functionally does early retransmit, functionally does FAC, but the mechanisms are completely different. The mechanisms are much more, RAC is similar to those mechanisms, but they are different.
I guess my question was, since the Linux code seems to be in so much churn in terms of they wanting to go to only TLP plus RAC in the future, for example, and remove to thresh. So my question was, are we going to track that here? Is that a goal?
I mean, in some sense, this document already depending on how you configure the constants, kind of already subsumes what.
Yeah, so
presented.
the Linux kernel might end up looking like Quic eventually, which is one of the things about Quic loss recovery again, is that it's a lot easier to do it with the Quic packet number format than it is to do with TCP sequence numbers, and that's a pretty big difference.
I'm going to give up the rest of my time because I think we have a lot of things to. Oh, sorry, I apologize.
My name is Yoshi Nishida from G Global Research. So I read the two version, and then there seems to be the two modes in the recovery draft. One is timer based, and the other one is ARC based in a sense. And so I don't know which mode has been used, which one we have to choose. That's very unclear to me.
That's a great question. So the Google deployment is currently still using the packet number based one at the moment, but it has both in the implementation. I don't think we're actually, my initial draft wasn't to provide any advice as to which to use. I would like to move to a pure time-based one, but there are application environments for which that's unsuitable. And so I tried to specify both, and you could even mix the two. So for example, you could have a 10 packet reordering window in packet number space, as well as an eighth of an RTT timer if it was appropriate. So it's a little bit overly broad right now. If you have any suggestions on kind of recommendations or how to provide some guidance on like what constants people should use, then like I would, an issue or a PR would be super helpful.
This is out of my curiosity, but do we have implementation of the current logic?
Yes, I believe I know the Quic code in Chromium implements this. At least it intends to.
It's based on this. So it's implemented based on this logic in their two version. That's what you're saying.
The code is very similar. Like the code to switch between the two modes is only like a few extra lines, and it's all in one method, just like it is in the document.
Okay, then if we use the source code, we can try this logic. We can
sure, you can. And I'm not sure. It's possible Quic Go also implements this. I don't know. Okay. I haven't looked at that.
Thank you. Thanks again.
All right. Let's move this up a little bit. All right.
Before you start, have people going to the mic, ensure that you have your badge visible, and that so we can actually read your names. It helps a lot.
Or even say your names.
Well, I'm Mike Bishop. So HP over Quic. Thinking about notable changes since the last IETF meeting was 0.0. So we've moved to a model where each HTTP request has a pair of streams, one for headers, one for data. We'll talk about each back in a second. Reworked how LPN and all service work, and we changed the settings format. In 0.2, as we decided that the interim settings get sent only at the beginning of the connection, so you don't need an ACK, and once you send settings, That's it, no changes. If you want to change something, open a new zero RTT connection. We have these header streams that are really sensitive because if you have loss on an HPAC frame, that gets ugly. If we get to the last presentations, I'll talk about that more in the QPAC draft. And we added a section on things you should know if you're coming from HTTP2, particularly if you have an HTTP2 extension you're trying to apply to Quic.
This may have been related to the previous discussion, but there was a comment on Jabber from Lucas Clemente who said that Quic Go currently has a WIT PR for it. Will probably be merged next week.
That was in the context of the loss recovery.
Okay.
Yeah.
So it's coming.
Thanks.
Okay. So I'm going to blaze through this really quickly because I assume most people know how it worked before. The original version, Stream 1, was crypto. Stream 3 was this kind of abridged HTTP2 session, but all the bodies happened on other Quic streams, which meant that you had a multiplexing layer at Quic and a multiplexing layer on Stream 3 in the HTTP2 layer. Number of people thought that was a little awkward. And so now as of 0102, you only have one multiplexing layer, but requests use two streams. So you've got one stream that carries frames, the other stream carries unframed data. Any questions on that, or should I? Okay. So we have HPAC from HTTP2 shoehorned in there currently. HPAC requires that you have processed all the previous frames in order. So we have a sequence number in there. That does mean we have some head of line blocking. It's no worse than it was before, but it's also not any better, which we kind of like it to be. There are two different proposals of what we could do in Quic if we're willing to depart from HPAC a little bit. I've got one I'm talking about later. There's also one from Buck Kresick, and the name of his draft has changed since I did my slides, but go look by his name or look on the mailing list. In the connection negotiation, we changed the LPN token. We changed how the version hint in alt service is done so that we no longer magically turn it from numbers into an ASCII string that's then sent as 4 octets. Instead, we just give you straight the hex of the 4 octets, which is going to be really short for the final version and a little bit awkward in the meantime. We need to talk about, we have different settings format. This is one that was proposed in HTTP2. The answer was save it for a protocol rev. Here's a protocol rev. Yay, we adopted it. If people don't like that, we can certainly roll it back. And it has a nice optimization because a lot of numbers that you send are either very small or they're Booleans. So with this one, if you don't send it, that's a false. If you do send it and it has 0 length, that's a true. The question that has come up on the mailing list as I was starting to gather things in for an HTTP2 transition section to talk about extensions is currently we are saying the IANA registries get modified so that they have new columns to say for each frame type, does this frame exist in HTTP2, HTTP over Quic, or both? And then specification links for each. The same thing is true for settings values. We actually departed from that for errors because Quic defines its own error format that HTTP is fitting into. But at this point, no HTTP2 frame is the same in HTTP over Quic. About half the HTTP2 settings are different, or half of them are gone, and one of the ones that's left has different semantics. And so I'm questioning whether it is worth continuing to have this IANA registry straddling both protocols, or if we should just split off and have separate IANA registries.
So Martin Thompson, we have this on the issues list later on, in case people felt inclined to jump on mic at this point. Let's leave it till then.
And I think that's the last of my slides. That is the current state of HTTP. Let's move to issues.
Thanks. Just leave the clicker up. Yeah, leave it up there. We might have a couple more presentations. So that's where we're at. That took a little bit longer than we thought it would, or hoped it would, perhaps.
Issues. So we have an hour for open issues on crypto, shutdown close, HTTP, non-crypto, and so on.
So first up,
Oh yeah, I've got a presentation on that one if you want to.
You do?
I sent it to you.
Well,
I certainly did. Oh yeah, I have email evidence of it.
Would it be helpful to show it, or?
Yes.
I really think it would be helpful to show it.
Okay, send it again, and I'll upload it while you.
Let's go to the next one.
All right, so we're dashing a little bit.
Oh, I mean the next like real issue. Yeah.
So shutdown close.
45 instead, please.
Oh, sorry. Mike.
Oh, this is old.
Yeah, so we never really closed the deal on this one. This is the problem.
Okay, Mike Bishop. So basically the idea is you do your handshake on stream 1. Right now, the only handshake protocol we've defined is TLS, but you have to know what you're expecting to find on stream 1 before you go in there, and the client has to know what it's sending on stream 1. And currently, there's nothing that explicitly says how you think that should come out. The proposal on the issue that I thought we'd all agreed on was that version numbers imply a particular crypto handshake. So if you see one of the version numbers that we are producing in this working group, it'll be TLS. If you want to use a different handshake, pick a different version number so that the server knows what it's looking for when it gets there. If anyone thinks that's a bad idea, please speak now.
I intend to write that down if someone doesn't object to it.
You get people moving to the microphones.
Sibyl Danger. So we've had this in the past where so the version negotiation itself is authenticated in the future by the crypto protocol that you use. And so one of the things that weirds me out about this is that you are negotiating the thing. So if there's even one, for example, like weaker crypto protocol, if we discover a weaker crypto protocol in the future, then if you allow the use of, for example, version negotiation to cite the crypto protocol, then the man in the middle could force you to choose the weaker crypto protocol so that you would then validate against the weaker one.
What you're saying is absolutely true, but that's the only way to fix that is not to have any crypto protocol negotiation at all.
We have discovered crypto protocols, and so my general, I am supportive of what Jana mentioned the last time in the interim. We had this discussion in the interim where we changed the model where the application chooses the crypto protocol and the version and the quick version that it wants to use. So it seems like these are two separate things explicitly where, well, we could argue about whether these are two separate things or not, but what's going to happen is that the Quic, I imagine that Quic is going to evolve really fast, and the features of Quic are going to evolve really fast as we discover new requirements of transfer protocols. So even if we add one more crypto version, what's going to happen is for each Quic version, we might want to like it would have a duplicate version for each handshake version. So it's kind of weird that an application would specify like, I am usable with these crypto versions, and it seems super weird to me. So if you say TLS is usable, then that's one protocol which has a version negotiation built into it. You could argue that TLS itself is multiple versions, but I think that TLS should be considered one version. Yeah.
I'll let Ben go first.
Okay.
Ben Kaduk, I just wanted to quickly, sort of point out / ask that if your security is limited by the weakest mechanism you support, are we planning on seeing versions and crypto mechanisms that are not the product of this working group? And are we really comfortable with people using things that haven't had enough review?
Well, I'll answer that, and then I'll answer the other question. No, I'm not particularly comfortable with that, but that seems to be what people want. So that's where we're at. So Martin Thompson, the concern that Subodh raised is an interesting one, and it's one you can actually have both, in the sense that if your application protocol says you can only use TLS ever, then you avoid the concern that you have, and maybe HTTP can do that. And that still leaves us with the opportunity in those cases where there are other application protocols that need other handshakes, or application protocols that maybe don't care about getting the lowest common denominator, weakest handshake protocol problem. They can say, just go off and do your thing. But I think we can probably solve it both ways. Otherwise, as Eka says, we're kind of stuck with just saying, well, we either have the problem or just fix it to TLS, which I don't think we have people being very happy with.
It's about anger. So I'm not exactly sure what point you were trying to make, Martin.
So I think I can fix your problem for HTTP by saying, when you use HTTP, you must use TLS.
So that would be great, but like if we specify in the draft that if you want to use a new, if we like write down in the draft that, hey, if you want to use a new handshake protocol, you must define a new quick version with a handshake protocol in it. And nothing prevents a person from doing that specifically, which even without that language in the draft. But putting that language in the draft means that it's explicitly saying that, hey, you must, all new handshake protocol versions are defined by new quick versions.
I mean, so that seems to me there are three alternative technical options here. One technical option is to have one handshake protocol is to have what's written down here, which is to have version number indicate crypto handshake protocol. The second option is to have multiple handshake protocols map the same version number with no explicit wire indication, effectively being, as you suggest, like UDP port, for instance. The third is to have an explicit wire indication. As far as I can tell, both of those, the reason the second one is secure is because the client knows what it's trying to accomplish and therefore will not accept a different protocol. But either the first or the third, where you have multiple handshake protocols riding on the same substrate, where the client is going to negotiate between them, and there's a wire indication for that causes that negotiation, like necessarily falls down on what the weakest handshake is. There's just no way around that.
Jana, and by substrate, do you mean same UDP port?
No. Yes. Like basically, it's like if the client is willing to do TLS and blah, it doesn't matter whether the way it spells that is I would do Quic 10 and Quic 11, or I would do Quic 10 with TLS and blah. Those are the same thing. I mean, from a crypto security perspective, not protocol physics.
So just to confirm my understanding of what that turns out to mean for the application mappings, an application mapping may specify that it requires a particular handshake protocol. And so the generalization of what Martin was saying is that if you're writing an application mapping for HTTP, you may say that the handshake protocol, which is currently permitted, is TLS. And any other application might say TLS plus or
Sure.
just the plus. But it means that in turn then needs to be an index into what versions include the appropriate handshake protocol, right?
Yeah.
Okay, so
I
there's
think
a
so.
set of three linkages there, and we just have to keep them linked.
I think so, yes.
Mike Bishop, and the draft does already say that an application can restrict what quick versions are acceptable.
I want to let Jim go first, but I'm getting you after.
Jim Roskin, just trying to follow this discussion. There's a top level protocol, and there's also a crypto protocol. Traditionally, with the crypto protocol, to prevent downgrade attacks, there was always you try to record a history of the log, what caused you to downgrade, I thought. And so is the suggestion that we omit from,
no.
I'm trying to, so the point is you both agree you support 10 or 11, but you really want to use 11.
Yes.
And then you're only using 10 because the other guy claimed I can only do 10, and then you have this downgrade attack. So usually you just say at the final, look, we decided on 10, but only because we both agreed you can't use 11, right?
Right. I think Subodh is hypothesizing some protocol, but that 10 is so weak that it doesn't even fight up. Like imagine 10 like was actually ROT13, then that doesn't work, right? So that's how you get in this situation. I mean, that's how, so I think that's what he's saying.
So, Jana, I'm not going to put words in Subodh's mouth, but the idea of actually requiring TLS for HTTP seems to be sensible to me. I don't know that I think that the application mapping knows what transport with what crypto it needs, and saying that out loud should be adequate. Yeah, as long as we agree that there's nothing else that's going to be running on UDP 443, that should be fine.
Yeah, does it maybe make sense to give a recommendation if you want to change the encryption protocol that's the only change you do in this version? So you have like two equivalents of the other protocol functions?
If you like combinatorial explosion, sure.
Yeah, I'm not expecting too many crypto protocols here, but
Nor am I. That's probably a good thing.
maybe like one more comment. I think the only case I have in mind that might be useful here is if you have like pre-shared keys, and I don't want to permit this case. So that's
You do TLS anyway.
out of band somehow.
You do
magically
TLS
appearing.
anyway. I can explain how later.
Hey, Igor Washinsky. So I actually wanted to go. I actually want to go back to the point that he was making. If you have to rev a protocol every time you want to add new crypto, you will have a combinatorics explosion. Let's say you get to 20 versions of Quic, somebody comes out with a new type of encryption. Now you have to create versions 21 through 40 of the same things, just using a new crypto protocol, right?
Ted Hardy, a clarification. I don't think what we're talking about here is new crypto algorithms or similar. We're talking about new handshake protocols. So the number of times somebody replaces the TLS handshake protocol should be many fewer than the number of times they create new crypto algorithms or similar for use in it.
So
yes.
So the TLS version is negotiated in the TLS handshake.
Right, so this
and
is
all you're doing in the version is saying this application mapping uses TLS for the handshake, and then inside TLS you can still do all the negotiation you would do for TLS, and that doesn't have to change the version of Quic or of the application mapping. But sorry if that wasn't clear.
Okay, cool. Thank you.
This is DKG. So I just wanted to point out that what we're actually not saying is that the crypto protocol for version 1 is TLS, but that it's TLS 1.3 and higher.
Yes,
Is that what we're saying?
Yes.
The shorthand. Right. Okay. But just to make sure that that's clear, and it's conceivable that a new version of Quic could be TLS 1.4 and higher.
Yes, and the way you say that is you say Quic version 92 mandates 1.4 and higher. Though on the wire you would still have the same one.
Jana, but if you're actually specifying this in the HTTP mapping document, we wouldn't have to do this with Quic versions, right?
I don't think that's true, because you still are going to have to say, and these are the versions which meet that, and keep that linkage. You don't have to do it inside the document itself, but the idea is a set of Quic versions will be TLS 1.4 and higher. If the application mapping says TLS 1.4 and higher, you have to keep a mapping of which versions actually meet that requirement, or you have to go into the TLS exchange and then reject based on TLS version mismatch. You can do either one if it's simply a version, but if it's actually a different handshake, you're going to have to keep a mapping of which versions do that handshake. So if it's TLS and let's say Martin Thompson's fancy crypto, you have to keep a list of which versions do both TLS and Martin Thompson's fancy crypto in order to keep that done.
This is Ben Kaduk, and DKG's point about this is currently Quic version 1 uses TLS 1.3 or higher for the handshake. We don't get new versions of TLS very often, and we have a lot of bits in the Quic version number, so we should probably consider just saying Quic version 1 uses TLS 1.3. I'm not saying we necessarily should do that, but we should consider it instead of TLS 1.3 or higher.
It currently says or higher, and I think that's fine.
Igor Lubasheva, Kamai. I think at interim we talked about the problem when there is a new version of Quic and it's preferred and the client got it first, then going to a server, if the client gets basically version negotiation, server doesn't understand it, the client is likely to cache the less preferred version as the version for that server so that it doesn't go and redo negotiations all the time. So that may delay the time when the actual client will upgrade its version, because once even the server upgrades the version, the client will keep going with the old one. Do we think that it's a problem we need to fix?
Mike Bishop, that's a problem that we've already fixed, because and part of the transport parameters that you exchange via TLS is the server's full list of supported versions, regardless of what the client asked for and agreed on. So the client will connect one time with the old version it remembers, finds the list, and then it has the choice whether it wants to continue on the older version and upgrade next time, or immediately kill the connection and start a new connection with the new version.
Okay, so the TLS layer will know about Quic versions.
No. The blob that gets handed to Quic by TLS includes the list of versions.
Jana Iyengar, I'm lost at this point. I'm trying to understand exactly what's going where, but I thought that the application, so if I'm reading this text correctly, the handshake protocol, which is the version of the handshake protocol, am I right?
Yeah, site version.
So it's TLS version for in this particular instance, TLS version would be defined by the Quic version, and the application mapping, in this case HTTP, would say what handshake protocol TLS is acceptable. Is that what the text is supposed to be saying?
Maybe I misunderstood, but it's probably important to be clear here. So my understanding was that what this PR was intending to say, and what you're intending to write, is that if and maybe John understanding the same thing, that for Quic version number 20 or whatever it is we stick on the wire, that means that the thing in the client hello is always TLS, and that the profiles will specify a minimum TLS version if they choose, but the minimum version will be 1.3. Is that what you're intending to write?
That is correct. So for any given, for the given version of Quic that we end up specifying, it will say that version number that you put in the wire means that the handshake protocol is TLS 1.3 or higher.
So what's the application mapping doing?
The application mapping will say that only versions of Quic that specify TLS 1.3 or higher can be used for HTTP.
Which is equivalent to saying Quic version X.
Right.
Okay.
I don't want to confuse Joanna again, but I guess you could even like the mapping could also say you have to use 1.4 or higher, and then if 1.3 is negotiated, you just stop the connections and make that, right?
Are we done?
No.
You do realize that we're losing time from more important issues.
I agree. Yeah. So we could do the discussion afterwards, but
anyway.
Subodh Iyengar. But I just wanted to make the point for the record is that I think that the Quic version should define the transport, and the application should require which crypto protocol it should use with that transport. That's what I am explicitly saying.
Somebody remotely was going in and out of the mic queue. If the going out was a mistake, go back in and we'll unmute you. And otherwise, we're gonna.
I think it doesn't sound like we have consensus here, but we can record kind of where we got to and move on from there.
All right. Martin, did you send the slides that you wanted to show for the first ones, or do we keep going?
Yes. Do we actually not have consensus, or we just have Subodh?
Sorry. We can do some non-TLS issues because maybe
let's go to the next
gives you
one.
some time.
Go to the next one. I didn't realize that I had to send them again.
The next one is then 61, silent close. Stuck? All right. Is it your browser or is it? Mine works.
Nice.
All right, we're done. No. Yeah, so 16.1 is a Martin Thompson issue, unfortunately.
Most of them are.
And it's from.
What does it say?
It says, I think.
61.
61, called Silent Clause. I think that this one or other peer walking away from a conversation without saying goodbye. If we're going to talk about silent clauses, we need to explain what it is, why a peer might choose to do it, and what the consequences for everyone involved if they.
Oh yeah, silent close. This is a fun one. So we've had a bit of discussion on the list about this one. So the basic premise of the suggestion that you're not connected to the internet.
Are you using
Quic?
Quic?
So I know all of that. I've got the memory now. We had a discussion about this on the list, and Jana proposed probably the most extreme version of this, which basically entails the following. And this discussion is all now out of date based on what's happened on the list.
This was deliberately extreme.
This was deliberately extreme. And this basically said that graceful shutdown is the responsibility of the application because the application is the only thing that actually understands the things that are going on, the state that it has accumulated, the streams that it has, and what it takes to reach the point where it can say, we're done. And so the conclusion there was, and again, this is quite extreme, is that the application reaches the point that it says that it's done. It does whatever signaling it might need to do to convince the other side to stop doing whatever it's doing, and it reaches the point where it's reached equilibrium, and then it just kills the connection, and the transport just says, thank you, I'm going to go away. Just doesn't say anything, doesn't send any messages, it just goes away. And there's discussion in there about what you do when you want to do it. I mean, HTTP will have a sort of an idle timeout, and it would recognize that on both sides, and it would have some negotiation for those sorts of things. And it would do things like close down streams to make sure that everything had been flushed out cleanly. But essentially, HTTP would reach the point where it had reached the stable state and just kill the transport, and the transport would comply. The discussion on the list sort of noted that in the case where you do want to do a graceful close, it's kind of handy to have all of the retransmissions happen at the transport layer, because this is a generic property. So if you have any spurious retransmissions that come in, all those sorts of things, it's nice to have the transport there with a timer running so that it can recognize the fact that this spurious retransmission coming in was associated with an old connection and can sort of cleanly handle that rather than sort of spin up a whole new state as if this were a connection only to discover that it can't process a client hello from that packet, for instance. And so I think the state that we're reaching here is one where, I realize now that I really should have put slides together for this one, is that the transport protocol has some very basic capabilities for graceful shutdown, and it's largely just this timer. And in fact, the timer exists even in non-graceful shutdown mode. So it's more, the transport protocol will define some basic shutdown primitives, which involves a timer for dealing with sort of lagging messages. And then the application protocol will be entirely responsible for doing graceful shutdown. And so in HTTP, we would define a go away frame, resurrect that thing. It might look a bit different to the way that it does in HTTP2, so fine. And then we end up in a situation where the application protocol does all of the graceful shutdown stuff. It has the idle timers and all of those sorts of other things. It has the other effect of moving the idle timer, which is now a connection parameter, from the TLS handshake into the settings frame of HTTP2.
So Martin, let me just see if I understand this proposal before I say anything about it.
Okay.
Say I'm developing a new Quic application, say SSH over Quic.
Yes.
And You know, I'm in my local machine and I do, you know, twiddle dot control D, right? Yep. What is the effect on the other side? Does any message get sent telling him I'm shutting down?
So SSH would define the messages that are necessary to do the shutdown, and I imagine it would send the control D over the channel to the other side. And the other side would acknowledge that, and there'd be some sort of arrangement that goes on in SSH. Once both sides have done that signaling, they would both tell the transport go away, and the transport would go away.
And if
virtually
SSH
immediately.
never bothered to find that, then their guy's left hanging for 2 hours. Right. Yeah, it seems kind of sad. I mean, I guess I'm fine if that closes abortive and says, I don't care if you receive any more packets, I am done. But like the notion that we don't provide any sort of nominal mechanism at all for saying I'm done, so you can clean up your state now, seems like not very great.
So what could an application like this do otherwise?
Well, I mean, and my point is that the abstraction that well, no, I mean, I'm saying the application. I'm fine with the applications with the onus on the application being if you want to have graceful shutdown, that is, you want to ensure that packets are delivered and know it was delivered, then you have to do some crap. But if the idea, but it is a pain for both sides if someone just goes away all the time and you're left with hanging state. And I'm not saying that never happened. I'm not saying it can never happen. I know people, it don't happen ordinarily because people throw out the radio and that kind of stuff. But to like have that be the default state unless someone buys the application specification seems kind of silly.
I don't think so, Jana Iyengar. I don't think that it's quite that. So in the SSH case, if all you wanted to do was, well, the client's been idle for a while, so it just decides to close the TCP connection right now. In this case, it would be the same thing. It would simply close the Quic connection because this is an application that doesn't require an explicit messaging over the wire.
What appears in the wire to cause the other side to know you've hung up?
The other side would find, because the Quic connection.
No, I'm saying I terminate SSH, right? So now in TCP this would be gone, and you get a FIN or an RST or whatever the heck you got, right? As the other side now, like, well, yeah, no, but in this case you do. But TCP attempts to deliver that thing.
Yeah.
TCP tries fairly hard, right? And so, I mean, again, I'm not saying, like, I understand the point Ian's made a number of times, which is the applications do just go away. That's fine. But I'm just saying, like, to move the equilibrium from people generally get cleaned up to people never get cleaned up seems like unwise.
Yeah, could have been. So what's the disadvantage of sending some kind of stop or fin signal or whatever to the other end?
It's Jana Iyengar. It's a packet that is sent after a long period of idle. And even TCP servers, for instance, are choosing not to do this simply because you don't want to wake up a client that's not on cell, for instance, just to receive a packet that says this TCP connection is going away. If you can simply arrange for a timeout before you even start the connection.
So, but you could still have the signal in cases where you need it.
Right.
Like,
so the suggestion there is that the application protocol would be responsible for doing so.
We have a Martin Thompson remotely also. So Stuart.
Stuart
Sorry.
Kersher from Apple.
Too many Martins.
One of the things I believe is in charter for Quic is to figure out consciously what information we want to expose to middle boxes and what we don't want to. And the TCP fin or reset is how middle boxes know to tear down state. And because they can rely on getting that 99% of the time, they don't need to be super aggressive about scavenging, reaping connections after the state's been idle for 5 seconds. If we don't provide any signal to the middle box that you're done with this connection, it's going to make it hard to use Quic for any long-lived connections because the scavenging timeouts will just continue to be really short like UDP.
All right, Martin, Duke.
Yeah, Stuart stole a lot of my point, but there's a bunch of related issues on GitHub about the about connection close. But one of them is to completely get rid of the connection close message and just always send a public reset, possibly with a no error code, which would solve the issue that Stuart is addressing. I also want to say that it's true that it would save a packet at the transport layer to not send the message, but at the but we're just offloading that requirement to send a packet on the application, which doesn't necessarily save you any power.
Janayang, I'm just going to quickly respond. I think this is the foundational. I think if you leave the mechanics aside, I think that can be figured out. We can figure out how to do timers and everything else, and we could ship them between the transport or the application. I think the question that what Stuart raised is the question: should we be sending? Do we need to send a connection close packet from Quic? I don't think we do, and I'm disagreeing on the premise that this is a significant cost to the endpoint. NATs currently don't do this, meaning they don't look for Quic connection close packets in order to maintain their binding lifetimes, which means that Quic endpoints have to deal with NATs that will rebind anyways. If you have an endpoint that's dealing with rebinding, then what's the benefit of having a NAT binding just lost longer? Leave it at that.
Ian Sweat. I wanted to say, I think we might be conflating slightly two separate but a little bit related issues, which is that there's the issue of whether you send a packet at the very end, which is interpreted as a reset or connection close or fin or whatever, and whether the concept of a clean shutdown and all those shutdown semantics are at the transport layer or they're at the application layer. So, I mean, personally, when we first talked about silent close, we do use this now in Quic, and it's more of like an application layer construct. But essentially, what it's telling we're basically telling the transport layer, hey, if you don't get anything in this amount of time, like just kill it and don't do anything. But I think they're two separate issues. And Martin's point about we really need a connection close, and Stuart's about we really need a connection close signal is a little bit different from like where that lives, I guess.
So, Igor Vishinsky, Yahoo. I think I want to echo what Stuart is saying. Middle boxes are unfortunately here to stay for quite a while, whether it's load balancers, whether it's NAT devices, whatever, right? I just accept it. It is really, really important to be able to signal to them that your session's going away. It's okay for me to clean it up. Because while right now that's not much of an issue because majority of the stuff is still TCP, in a world 2 years, 3 years from now, when Quic gets adoption, it could be the majority of the packets are Quic. And those things are going to go, holy shit, my state is exploding. I'm going to start randomly killing shit. And I think it would be very short-sighted because we decided to save one packet. We're going to end up in a state that is really not good in 2 to 3 years. So I'm completely with Stuart here. Like how it's done is a different question.
Philhan Baker. Yeah, I agree with Stuart, but there's a couple of things that come to mind. One is do you even want to maybe have an explicit role for the middle box to be able to say, hey, I'm about to tear down this connection. Please don't. Are you using it? And one of the problems that comes on is that could be a really good idea, or it could be a really, really bad one, depending upon how the middle box people react. So you probably need a document to tell middle box people how you would like them to react, accepting the fact that they may not take your advice. The other thing that comes to mind is one of the things that you might be using Quic for is for connections that have much longer lifetimes than TCP does. Instead of it just being used for web browsing, if you're using it for a web service, you might want to have it up for a week. And so there may be some real issues that the middle boxes want to get into there. And so what you might want to do instead is to think about, well, what happens if the session state is torn down at the middle box, and how should we detect and recover from that transparently so the application doesn't need to think about it, as opposed to the other way. So it's complex.
This is DKG. I have 2 brief points. One of them is that for questions about load balancers, presumably a load balancer is in an explicit agreement and an arrangement with one of the endpoints of the communication. They don't need, excuse me, they don't need in-band signaling for the fact that they should tear down state. If one endpoint, the load balancer is operated by someone who has an arrangement with one of the endpoints. So I'm going to make that point and leave it there. If you want to get back and argue about that, that's fine. The second point is that we're talking here about connection close as though it's something that's always visible to the middle box. We have a third option, which is a transport layer connection close that's only visible to the endpoint.
let's go to Mark. No, did I do first or Martin first? I can't remember.
Let Martin.
Martin, all right.
So I just want to say the middle box visibility issue is actually quite coupled to the application layer or transport layer issue, and people have been dancing around this a little bit already. But if it is an application layer message, or if it is the connection close message as currently described in the draft, it is invisible to middle boxes because it's encrypted. That doesn't do any good. It really has to be a public reset to have this state clearing that the middle box guys want.
Thank you. Stuart, and I think we need to close the mic lines on this, unless we want to spend the entire rest of the session on this topic.
Stuart again, I'll try to be quick. There's been some good discussion on this issue, so I want to elaborate on when the NAT binding matters and when it doesn't. If you view the world where everything is initiated by the client, then the NAT binding or the firewall state is soft state and it can be recreated on demand. So I do another request, then that's forgotten about me. It doesn't matter. It makes a new binding with a new external port, but the connection ID goes through and the state at both ends is reconnected. So that's fine. There's no problem. Where there's a problem, if you care about this, is when the message is coming the other way. So if I have got a connection open to an IMAP server and I don't want to be polling it every 5 seconds saying, do I have mail? Do I have mail? Do I have mail? I just want to say, let me know when there's mail. I then go silent. And if the NAT times out the state, the server is trying to tell me you have mail, but it's not getting through. And I don't know it's not getting through because I don't know the NAT state is timed out. This can happen in web browsers as well. I'm on the Burning Man ticket page waiting for a ticket, and I don't want to keep hitting reload, reload, reload every 5 seconds. The server says, okay, we've got your request. We'll let you know when it's your turn. But if the binding times out, I see the little animated man not making any progress, and I don't know the messages aren't getting through.
This is DKG. This is a problem anyway, right? Regardless of whether we have explicit close, because some clients will just go away because they run out of battery or they crash or they change networks. So that there is going to be a requirement to, if the network is not going to keep a path open, then there's going to be a requirement for the side that's expecting a response to try to signal to keep it open at some frequency. The existence of a connection close doesn't solve that problem.
It doesn't solve the problem, but it changes the common case. Because if you can imagine that the client going away unexpectedly, unannounced, is a relatively rare occurrence, then it's a corner case you have to deal with. If that's 100% of your traffic, then suddenly that becomes your only mechanism for scavenging state instead of being your backup safety net.
Okay, so we have a half an hour left. So I'd ask the people in the queue to be really brief and people to refrain from responding.
Can I make one response at the end?
Oh, John, your response is in the draft.
So, going first, well, +1 to Stuart then. Let's design for other apps. Let's not force these things to do timeout-based stuff when we can actually signal stuff and actually see it in the network and actually understand what's going on in that device rather than just having to imply it. So I think as we move on to the simple, rather than just web browsing, we look at other uses of the technology. This explicit clause that's visible is really good.
Yeah, I thought Jim Roskin, I thought it was a great discussion. And I'm happy that we're not trying to resolve it here, and you're going to cut people off. And also, just to point again, in some applications, you really care about not waking up the stupid cell phone and using power just to say, I don't have anything else to say, and that's a big deal. That's one constraint in one application. In other cases, you're talking to a NAT. Another interesting case is when you have an adversary out on the web who's trying to reset your request. Not that happens in certain interesting countries with large firewalls, and they want plausible deniability. So it's interesting to be sure we factor all these things in to and I can even imagine a case where you're told the middle box is told it's shutting down, and he still applies a timer just to make sure that it wasn't a lie and someone doesn't get a chance to correct it. But we need a way to talk to these middle boxes in a nice way so everyone knows we're on the same page.
Ben Schwartz. So anything that assumes that we're in the state where Quic hasn't yet been deployed is false. Quic is widely deployed, and so it does work. It does not require changes to middle boxes in order to work. It works with current middle boxes. those middle boxes are going to be around forever. So there's no way that we can introduce some dependency on that behavior. We have to deal with the network as it is forever. And finally, the adding an exposed packet that indicates the end of a connection is a serious privacy leak, because when you reveal the duration of your connection, that's something that can distinguish, for example, a long-lived connection like a VPN from a series of short-lived connections like web connections. So there's an additional leakage beyond just packet lengths and the lengths of when those packets are sent. If you also add an additional bit that tells you this is an explicit end.
Thanks, Ben. Is there anything we can reasonably record to move this along, or should we just move on?
So Mark, I think I understand what people are saying here now better than I did before, which is that everyone wants to talk about the explicit close thing, which is not at all the intent of this issue.
No, but except, Martin, except it's called silent close, which is
right,
which
Right.
makes it the intent. So I think
There is the presumption here, and the mistake with this issue was that we recognize the fact that this silent close thing exists and we're looking to leverage it. And it turns out that people are really unhappy about the silent close thing existing in the first place.
And I think that's going to be a valuable discussion to have, because I think we do want to talk about that specific issue.
I hope someone captured what I just said, because that's important.
Magnus, could you put that in the issue, perhaps, if you have it in front of you?
You guys need to take him drinking, because I think the intensity of the discussion is much higher than the normal working groups, and he's minuting and all. So you don't have the gaps at the mic line that they normally have.
So, Martin, I found this, but you look like.
That's the one. Yep. But these are the slides. Google Quic has a feature whereby unprotected packets have an integrity check. And this recognizes the fact that the UDP v4 checksum is not very reliable. People set it to 0, and simply it's just not very good. So the consensus at the interim was that we would put something in. The challenge was that no one could decide what that was. Next slide, please. So I'm going to present Unicode problems. Nice. You have to embed the glyphs. It's terrible. So I'm going to present an old option, a new option, and the Warhol More crypto option. Next slide, please. There you go. I consider these to be representative of the things. Obviously, there is a very long list of things we could use here. What I really want to do is reduce this down to something simple. Remember here that we're looking for an integrity check. It's a checksum. There's nothing more to it than that. We're looking for something better than the UDP checksum and not a lot more. Please pick one. And I would prefer a hum or something along those lines, so that we can resolve this issue, because I'm kind of sick of it. Victor.
No, Echo was first.
I don't care. I'm going to pick your talk.
And then I'm going first. All right. Jana Iyengar, the one thing I will note, and the context is kind of useful here, that Google Quic right now, deployed code, uses FNV1A, 128-bit FNV1A. And the important thing I want to note is I asked Adam Langley why he chose FNV1A, and he said because it was simple to implement, it's a handful of lines of code, and it does the job remarkably well. And that was the only thing he said, but that's useful bit of information. This is deployed. We already have code doing FNV1A.
So, I mean, it seems like, I guess, from my perspective, given it is absolutely, of course, true that it is nice to say and simple to implement, but it's even nicer something that is you already have. And so there's extremely high probability you have AES GCM. And So it's also worth noting that you don't have to, that there's actually a prime variant of this, which is just have the entire packet treated as additional data. And now you basically just have GMAC over the packet.
So now you're doing exactly the thing that I was wishing people didn't do, which is suggesting alternatives and variations. But yes, that's a good point to add to that.
Well, I guess I would say either GCM variant seems dominant for that reason. Yeah. Okay.
Victor Vasiliev. So, Martin, are you going to go explain the differences in the implementations between those yourself, or
Oh no.
do you want me to?
I don't think it
express my-
matters. If you would like to suggest that it does, then please go ahead. Differences, other relevant differences here is that the first one's smaller. Knock yourselves out, people.
So CRC32, annoying if you don't have hardware support, but you just roll a lookup table. Most platforms have hardware support. FNV1A, literally 5 lines of code, and literally why it was picked by AGL for initial thing. ASGCM, like you already know, it's just you do more crypto, but other than that, it's something everyone already will have.
Jana, just one thing I want to note, that this is for the unencrypted packets at the beginning of the connection. This is really important because we're not talking about a hash for the entire duration of the connection. We're not talking about the lifetime of the connection. This is the first maybe 1 or 2 packets, and that's it.
Hi, Nick Sullivan. Clarifying question. Is this AES GCM or AEM GCM SIV?
I mean, I would assume it'd be GCM regular because you're not carrying the adversarial integrity, adversarial problems, which is the only reason you have a problem with GCM nonce-repeats. I mean, this is GMAC is what it really is.
Victor Vasiliev, this another thing to note is what Tujana said. It is only used for handshake, but it does show up in profiles. So it's not entirely unimportant for this to be performant.
Do you have your information?
I don't have my information.
Okay.
Because people are arguing for all 3 of them equally.
Well, what did he expect? Jana, our running code uses FNV right now.
See?
The remarkably unpersuasive argument, Jana.
Exactly.
Well, I thought we believed in running code, but maybe not.
We could put 2 coins and we
I
could
thought
put
added
2
line
coins
was
and
enough.
add the 4th option, which is don't do this. And then we just have to flip 2 coins.
So Martin Duke? Oh,
Hello?
go for it.
Okay, quick question. So if we use AES GCM, does that mean that an implementer just basically always uses the same code path where he sends it through his crypto, and it's just a matter of changing the keys when we go from unencrypted to
Yeah.
Does that mean
I
that all
would
the
hope
packets
so.
are encrypted technically, even though not actually secure?
Yeah, that would suggest not doing the AAD only thing
I agree.
that Eka suggested, which is a reasonable argument for this. Observing, of course, that if someone wanted to negotiate char-char, they would be changing the crypto algorithm.
Yeah, sure. But I mean, the way the code paths are structured, right, is that you have some generic encrypt packet structure that is then keyed by is then has a key structure attached to it. So I mean, in terms of the code paths, Martin's right. It's absolutely like the cleanest code path is to have that structure.
Yeah, I have no comment on.
Sorry. There's a latency here between. Go back in queue and speak, Martin. I can't put you back.
Sorry, it wasn't very
All
important.
right.
I just wanted to say I have no real concept of the merits of the 3 algorithms, but I do favor easy implementation, and it sounds like the 3rd is the easiest.
So, Mike Bishop, I would say if we're able to say packet protection is always the same and your pre-0 RTT key is just a fixed one, that's a very persuasive argument to me. Because then all packets look the same and are handled the same.
So to Martin Thompson, I find it less convincing on the fact that you can say that adding an integrity check is a different cipher, and you need to deal with the fact that you might negotiate a different cipher in TLS. So yes, it's somewhat persuasive, but it's not.
I mean, honestly, I would prefer something fixed for all time, because we've had the IP checksum for 30 years, and we're just talking about shifting that slightly to another one that we can have for the next 60 years. And it really doesn't matter that much more. It's not protecting the packet. It's not encrypting the packet. You're simply getting a checksum for the first couple of packets.
This is DKG. I also want to point out that if at some point in the future we decide that AES GCM is a bad idea, then we're going to have a discussion about, well, you can't actually rip it out of your implementation with an AES GCM die because it's stuck in this other spot over here. So it makes us really kind of commit to having that argument at the very least once we decide that AES GCM is bad.
New Quic version.
Why?
And using crypto functions for things that don't give you crypto property, Eric Nygren, using crypto functions for things that don't give you crypto properties that people think they might be getting is really dangerous, because then every single time there's a problem with that crypto function, people ask but I thought I was getting this property out of it, or hey, we need to stop using this because of this property I'm not getting from it. So it might be safer to use something that's not a crypto function.
It's about anger. I think I might be opening up a can of worms, but it's related to the previous discussion about middle boxes being able to delineate the start and stop of flows. I think that could also be considered here. Like, for example, maybe it might be easier for a server to deal with AES GCM, but a mailbox might be harder because they see packets coming from different flows to different servers and a much higher volume of them. So I don't know whether it's a different consideration for middle boxes versus end services which have to decrypt these packets.
Just reflecting from the room, Lucas points out that with option 3, a client cannot choose to only support Cha-Cha, but always has to implement AES, which I think goes with Eric's point very well.
So Martin, is this helping you a bit more?
This is helping me zero. So I have what I want from this room is A, B, or C.
I would like to add Adler 32 to the list.
I'm tempted.
Why not?
Change the one that's there if you want to do that, but
Okay.
let's make it A, B, or C, please, because this is ridiculous at this point. I mean,
Why don't we do this? Why don't we hum on the 3 and close discussion after that, and the editors can incorporate based on that information what they think
friendly
is best.
amendments will be fine.
And
yes.
then we can discuss it. If there's strong enough pushback afterwards, we'll figure something out. But I don't think we're going to come to a conclusion on this just by talking in a room.
Yeah,
and if I might add, just one of the problems is that it's not clear what the benefits. I mean, we talked about AES as having some things, but it's not clear, for instance, why CRC32C might be better than FNV. And this is hard to reason about because it almost doesn't matter between CRC32C and FNV, except that FNV is incredibly simple to implement and it's already implemented in running code. But yeah.
Yep. So let's go ahead and hum. I'm going to do 3 hums, 1 for each. You may hum for more than 1. So for CRC32C, hum. Okay. For FNV 1A 128-bit, hum. Okay. And finally, AES GCM with fixed key, hum. Wow. That's pretty strong feedback.
Does that help you?
Does that help you?
That's helped me a lot.
Okay, cool.
All right, so for the record, the FNV got clearly the loudest hum amongst the 3. So yeah, and the first one also. So it was at least where I'm sitting, they were very close, the first and the third. Okay, 4 hums and Jabber for B. All right. Now you guys know why we need 3-day interims, because this is the pace at which things are going.
No. To 27 was option C.
Oh, no, but I think this is.
330 is the same as Billy.
So you guys over here need to also use the mics. And Ian had a hand up.
There were requests, I don't know, there were requests from other people, including Martin Duke, prior to the meeting to, he wanted to talk about 391 and, or the various non-crypto options. I don't know how much people.
We don't have a lot of time, and we didn't agree to that earlier.
So in other words, that's a rat hole and we'll not go there.
Well, we can either do some more issues or we can move on to the presentations. That's what we've got. QPAC and ECN.
I'd like to see feedback. I think that's
I want to get the packet number echo thing done.
So 391?
QPAC can keep going, but
Yeah, plus one to that. I think QPAC isn't urgent. This is.
Okay, we've got feedback from the editors. We want to go here then. 391 first? Okay.
let's have the discussion about what middle boxes get to see again, shall we?
Should I pretend to be Brian? Or
Yeah, I mean, regardless of the encoding details, like I'm unpersuaded that we should be exposed to. I don't even want to expose the packet of information in the forward direction, let alone the reverse direction. So, so I think I don't say we can have this conversation, frankly, without having the conversation about the connection ID and the packet numbers as well.
should I explain this issue, or does everybody know what this is about?
Yeah, no, I think you should.
Yeah. So the idea here is to add another field to the exposed header, which is a packet number echo. So whenever you receive a packet, you look at the packet number, and in the next packet you send, you put this packet number echo, the packet number you've seen in the packet number echo field. And the only thing you do with this is you can do round-trip time measurements in the network, and you can basically measure. Like if you're in the middle of a connection, you can measure from here to one side and back, which is like half of the round trip time. And if you have the symmetric thing on the other side, you can measure like the other leg, and then you have like the whole round trip time. That's it. And I guess the discussion points are like, if we expose it, how often do we expose it? And yeah, these kind of things.
Jana, I'd like to add some data to this because that might be useful. Not data in terms of actual numbers, but Ericsson, Marcus from Ericsson posted something on the list, which is informative. There's the usefulness of this sort of information is not just for passive measurements, it's actually for deploying AQM in the network. Having RTT allows you to do AQM, and Ericsson did some experiments with this, and they actually saw that TCP terminating proxies that they had deployed, which you can't do with Quic because Quic uses end-to-end crypto. You could use AQM instead for Quic and get similar results for the proxies that they were looking at. Now, again, this means that this is a way forward for them to do AQM in the network, and it allows them to do that.
There's someone in the mic line.
Yeah, good. I'm just curious about this. The other echo packets or ACK packets that we get, they have this separate field that gets encrypted with the latency since the received packet was seen. So that it wouldn't be exposed here. So you would have different perceptions on the endpoints and inside the network. So would that still do the trick for you, or would you need to expose more?
No, so the idea here really is to expose a minimum. And like we also discussed timestamps or whatever, but it's just, you don't need that information. And usually it's also okay if you have a less accurate round-trip time measurement in the network than you have at the endpoint. Depends on what you want to use the information for, sure.
So is there any recommendation of how frequently this should be sent? Because it says it's optional, right? And why as a client would I even implement this, right? I don't get any benefit out of it. It just wastes bytes. Yeah,
I think the two proposals are to say something that you should at least send it once per round trip time, or the other proposal is you send it always. In principle, once per round trip time would probably give you the information you need in the network, but it makes it harder to find the information.
I mean, I thought there's a philosophical issue here, which is that, we're spending an enormous amount of time encrypting everything. And I understand the things in the middle which like to have that information. And if I want them to have information, I will give them that information explicitly. And if people want a round trip time estimator, we should add a round trip time estimator field here. What I don't want to do is create, what I don't like about this and about all these other proposals is creating a whole pile of backscatter radiation, which leaks information in ways I haven't been able to figure out and which I then have to reanalyze. So, this seems incredibly unpersuasive.
So this seems to be, just to answer this directly, this assumes that you already have exposed the packet number, right? And then if you have exposed the packet number, that's kind of the minimal information you can give on top of that to have what you want to.
Jana, I don't think the.
Jana said, do the
Okay.
other direction. You figure it out.
Ted Hardy. I actually disagree with you. The fact that the information is coming back from the other side is very different information from the exposure in one direction. And so I do kind of want to echo what Ecker is saying, that if what you actually want here is a round trip time estimator, making this optional on both ends so somebody can periodically send an optional round trip time token, and then the other side can optionally respond with the round trip time token.
Round trip time in the packet.
Sorry?
Put the round trip time in the packet is what he said.
Well, no, but the point is, if you want to do this such that you expose it to the network, because you want them to do AQM or whatever, if you want to do it such that you expose it to the network, so you periodically want to let the network reset its AQM timers, you could do this with an optional specified field for this without incurring the backscatter radiation problem at the same level, right?
Ian, but I wanted to note that actually I don't think that's true, because there's no round trip time that you want to expose to the network. It depends on where you are in the network. So for Ericsson and for almost everyone else, they want to know, what is my downstream RTT? They don't give a crap. I mean, they kind of care what's upstream, but that's not like what they want to measure. They're trying to optimize their network. They're trying to not to optimize the entire internet.
So, Ted Hardy, there are actually people who are trying to optimize the whole thing in CDN land, because what they actually want to know is whether the RTT is useful for a particular application context.
Okay. Wendy?
Okay, yeah.
In whichever order you'd like to take us, Wendy Seltzer. Also concerned about the privacy implications here, and there's lots of complexity here already in things that I'm hearing, and adding fields to the unencrypted parts of the packet doesn't seem to meet our later privacy
So
concerns.
do you think there is an additional privacy concern if you already have the packet number exposed, if you put the echo on there as well? Or is it okay?
Yeah. Jana, I want people to draw back just a bit. I mean, this is why this discussion is happening. If this was trivial, we wouldn't need a discussion for this. I think this is an important point, actually. I don't think the use cases are bullshit. I think the use cases are real. I think there are consequences of our design decision here that operators will have to bear. And this is why Marcus is standing behind in the mic, and I would like him to come up to the front and speak about this. But the experiment that Ericsson ran was to actually try and deploy AQM. For those who don't know, AQM is something we love. Transport people love AQM and want to see it deployed. And this is part of the problem, is that deploying AQM has a strange story in the network, where people who want to deploy AQM don't necessarily have access to the devices that have the queues. Those are much deeper in the network. And to deploy AQM further out, they need to have some sort of passive measurement capabilities. Now, this is a network management issue. It's a real network management issue. It could potentially be a privacy issue too, but we don't know exactly what those are. So the working group can go either ways on this, but I think we should have the discussion as though both sides are real.
So the problem is that with the B buffers having either no AQM or very old AQMs, it's very difficult for us to roll out new AQM solutions there. So we wanted to make a more centralized function that can solve this problem for a wide array of buffers. And the problem is that if we have end-to-end RTT estimates being explicitly sent from the client, then we don't know really. I mean, we want to have the RTT estimates from the point in the network where we are doing these measurements. And furthermore, what we used to do is deploy TCP proxies because it was easy. We could terminate TCP connections and deploy different congestion controllers. Now we notice that TCP is evolving quite rapidly and might not be a good idea. So what we see here is a much less intrusive way to achieve the results we want to by just doing passive measurements, basically.
Ben Schwartz. It seems to me that there's a useful function that we're describing here where endpoints can cooperate with an element on the path. But that function isn't particularly related to the rest of what Quic is for. It seems to me that this would be better solved by running something like stun on the Quic path, on the port pair, and essentially completely decouple the question of round trip time or partial round trip time measurement from the question of which UDP protocol is being used.
Xavier Marjou, Orange. So I understand that privacy is important and must be considered for anything which is publicly visible, but I think that having some degree of visibility for the networks is important, because if you want Quic to be always quick, you also need to collaborate in some way so that network administrators can see whether there are bottlenecks or congestions within the network, and having some degrees of visibility helps for that.
Eric Nygren, and I think this is one of those where having this available as an optional thing is one where if it gives the networks enough visibility to be able to manage the networks better such that they feel less incentives to do something crazy like deploying quick proxies, enforcing and sticking server certificates or CAs into end devices. If it can prevent that sort of thing by still allowing them to feel they can manage their networks, even though stuff is encrypted, it may be a net win on the privacy side. As long as it ends up being something that's optional.
And then please be quick. We have 4 minutes left.
This is Jim Roskind. One of the vague regrets I had for Quic was that people could not do TCP termination midstream in the middle boxes, and I was sad. At the same time, I hear this exposure, which is suggesting that we leak information, and then that gets me very scared. I do believe that it should be possible for middle boxes to cooperate, and this is a gigantic extension, but I would really like to be able to have middle boxes communicate back towards either end, and then we have the ends having the option of responding and interacting with them. And I believe this goes towards someone's shaking their head again. Anyway, it's just much bigger than what you're going for. But the interesting thing is, I'm afraid that this is a slippery slope statement of leaking information. Instead, I think ECN is a good example of a communications channel between middle boxes and endpoints, which is extremely helpful. And there's a trust but verify, so we don't have to depend on things. Anyway, I can go further offline with this direction, but I'm scared about the leaking, and I'm excited to see ways that we can work with middle boxes in a useful way. As I say, trust but verify.
30 seconds each, but
okay.
We stick with the floor mic first.
Okay, John, am I going first?
Okay.
It's Chris Silver from Hutchison. Just to say, I mean, we've been doing the round trip measurements with TCP for years, purely for network management. We're not interested in the traffic. We have no TCP proxies in there or anything. It's purely for identifying bottlenecks, congestion, and sometimes when there are custom complaints from a region or something like that. But I mean, I love Quic, but my concern is this loss of visibility purely for network management.
Jana Angar, I think it's really important to separate some of these issues out. ECN is connected to AQM. Without AQM, ECN is useless. And to do AQM, this is useful. So if we want to talk about network management, this is one of those issues, and this is one of those signals that we're talking about. And I think if there are operators in the room who think that this might be useful, this is a good time to talk about, maybe not today, but this is a good issue to talk about. And if there are privacy issues in this, it's also a good time to talk about exactly what those issues might be.
Really fast.
Yeah, okay. I mean, middle box vendors always try to analyze traffic and deduct as much information as possible from the flows they see. Having a certain set of signals that makes it more explicit makes it more easy to get it right, because we'll try to do this stuff anyway. So it'd be a good thing to.
Right, DKG, really quick.
Sorry, really quick. I think the fear about the privacy leak here is coming from folks who are not entirely sure exactly what the privacy leak might be or what the consequences might be. And I wanted to say that I think it's actually a very legitimate kind of a concern to have, because often you don't know what the privacy leaks are until things are deployed. Well, I know it's not. I'm just saying, like, I don't think we should dismiss the privacy. There's a temptation. I understand the advantage for network management. There's a temptation to dismiss the privacy concern because it's not concrete, and I think one of the issues with privacy leakages is that it happens and the data is leaked and it's permanently leaked. And so I appreciate that people bring the privacy concerns to the table. I'm also very nervous about including this.
So one option that we have, right, we have an interim coming up, is that we take some significant chunk of time there, but it would require that we have enough like operators and network managers at the interim. So if this interests you, come talk to Mark and me, and if we sort of feel like we have that crowd that would show up in Paris, we could do it. We could also do it at the following one, which is probably going to be between IETF 99 and 100, probably somewhere in North America. All right, so we're at the end of the, I want to remind people to please send us feedback about how this worked. I already gotten some. So how are the room, sorry? Oh, sorry, you were hidden. Are you still on the topic of privacy?
I want to speak about troubleshooting.
No, we
So it's not directly privacy.
We're
but-
out of time, sorry.
Okay.
We're out of time. So send us feedback about how well this worked for you. If you have ideas of how we can make this work better, let us know. If you absolutely hated it, let us know too, and then we're not going to do it again. Register for Paris, right? The deadline is in May. If you register early, that will help the local organizers get a better grip on stuff like food arrangements and things. So there's no need to wait until the last possible moment. Have a safe trip. See you all in Paris. Come up and sign the blue sheets.
So Mark.
Yeah, I agree. The microphones are still live, just so you know.
Yeah, I just wanted to